Welcome. We're going to do the answers to these. And those that are watching in Zoom, you guys can talk to me at any time. I'm just going to kind of go through these. I haven't done these problems. I'm just going to do them on the fly. So, I mean, it wouldn't be fair. And I could look these answers up. But if you have questions, just stop me. Number one, graph of the function shown above. Which value of x is f continuous but not differentiable? So it could, or this is continuous. Oh, so continuous means pencil test. So not B, not D. And differential, not differential means like sharp turn. So this is a sharp turn. This is smooth. So no and no. So A, easy. All right. Sharp turn, continuous. Done. All right. Got to move on to the next one. Drawing two. All right. If f is 2 plus absolute value of this for all x, then the value of the derivative, f prime o. I hate derivative with absolute values. Like, what you got to do is like, what you should, okay, the right way to treat this is like as a piecewise function. It basically looks like this. You have the equation 2 plus x minus 3 without parentheses, then 2 minus x minus 3. This one happens when x, I think this happens in the domain x is greater than or equal to 3. This one would be when x is less than 3. Something like that, because you have to like negate it, reverse it. Negate or reversed. And so absolute value is kind of our piecewise function. But so in the case where x equals 3, we can just use the top one. You just derive this, and the derivative of that thing would be just f prime would equal 1. So 1. Oh, wait. Oh, that is wrong. Why is it wrong? What's the correct answer? For this one, 5? It's not. This isn't one of those problems, though. For 5. But it's not one of these absolute value problems, right? No. Yeah. So for those watching the video, someone suggested it was supposed to be x minus 3 over x minus 3. Because a lot of times when we've seen limit problems, you've seen limit problems like, x minus 3 over, or maybe the absolute value would be on the bottom instead of the top. They say, what's the limit as x approaches 3? Okay, so it's not one of those problems. Just straight up. But here's the thing. Am I right with 1? So I derived it, right? And this is right doing the piecewise. Is this right? No. It's wrong. Correct answer is non-existent. It is non-existent because there's a sharp turn at 3. How do you prove that? Okay, so one thing with the, and the question's been at home. Okay, I'm getting another response saying the person at home was right. But it's not one of these problems. Wait, I'm going to keep going with my way, and then if you want to correct me in chat, you can. So the reason why it's non-existent, what does the graph of an absolute value function look like? It looks like a V. With the vertex is like where the absolute value always becomes 0. This one would be like, oops. So if you had the graph like this, y equals absolute value of x would be like, I can't even draw straight lines. It's straight lines at the vertex 0, 0. Like this, okay? And if I had the graph of like absolute value of x minus 1, it would have a vertex at the point 1, 0. It would look like that. So whenever you have something at x minus 3, the graph of x minus 3 is going to be at x equals 3 is going to be the sharp turn. But this plus 2 makes it like a vertical shift up. 2. So what you have is this. And the derivative at x equals 3 is going to be non-existent because we got a sharp turn. So one thing, so this was kind of a trick question here. Your derivative at 3, when I have the absolute value of x minus 3, is going to be a sharp turn. This is one of those you don't even have to really derive it. I think you should just know. I mean, I guess we derived it right here. Now another way to prove it, the derivative of the top was 1, but the derivative of the bottom is -1 on how I wrote it with the piecewise functions. Those different derivatives, so we're not differentiable at that point x equals 3. I guess the easiest way is to know with absolute value at that point where the absolute value of whatever equals 0, that's where the vertex happens. That may be something to remember, and that's where you're not differentiable at that point. Now, people in chat were correcting me. Flip it, and she was right. Okay. Where you guys, some people are saying it was supposed to be like this. Where are you getting this x minus 3? I don't know where you're getting that from. This isn't a divided sign, it's just 2. I know sometimes they're formatted weird. I don't know why it's a 2 plus this or not an x minus 3 and then plus 2 on the outside. That'd be better. Weird. But there's no divided by here. Yeah. Correct. Because it's a sharp turn at x equals 3. And you're not differentiable at sharp turns. How the graph looks. That was the correct answer. Go ahead, question again. Okay, you got it. All right, anyone else? Okay, anyone else? I think people read it wrong. I even guessed wrong the first time. Weird type of problem. Here we go. Good thing we're recording a video. This one. Hey, this is do you know the rule for exponents? So derivative, if it was e to the x, derivative is e to the x. When I have a different base, it's 2 to the x times natural log of 2. See. That's hey, it's not power. This isn't power rule. Power rule will be x to the x is on the bottom, the base. 2 to the x is exponents rule, and that's do you know it or not? Okay, moving on. 9. I'm recording this. It'll be on the YouTube. Okay, so this looks like a quotient rule to me. So on the top, I'm going to call it f, and then bottom is g. F prime times g minus f g prime over g squared. And my f prime, if top is links, the derivative is 1 over x. G prime would be just 1. So it's going to be 1 over x times regular g, x, minus regular f links times 1 prime over x squared. And what you can do to simplify, these x's kind of cancel each other out, so we're at 1 minus ln of x over x squared, like d. Questions? All right, moving on. I go too fast and stop me. Chain rule. Oh, is this a chain rule? We haven't even done chain rule. That's so annoying when they throw chain rule in these things. I try to avoid that. Well, chain rule. That should be cosine of 3x times 3. E. I mean, yeah, it's either you got that or that. I guess I can here. Let's do 13 on the bottom. Same thing. Instantaneous rate of change at x equals 2 of the function. When I say instantaneous, that means find the derivative at x equals 2, f prime of 2. Instantaneous rate of change. Rate of change means derivative. And at the instance when x equals. So it looks like a quotient rule again. my f prime would be 2x, g prime would be 1. So, okay, I say f and g. I know this is f of x. Oh, I'll deal with it. F prime of x is going to be 2x times regular g, which is x minus 1, minus regular f, x squared minus 2, I'm putting in parentheses, times g prime 1 over x minus 1 squared. All right, now I would clean it up slightly. I don't want to clean it up. Like really just plugging in 2 right away. But we can do some slight cleanups. Like we don't need this 1, right? Okay, so I'm going to go 2 times 2. 2 times 2 times 2 minus 1. You don't have to write all this work. 2 squared minus 2 all over 2 minus 1 squared. All right. Well, okay. That's going to be 4 times 1. That's just 1. It'll be 4. This is going to be 4 minus 2. So this will be 4 minus, and this one's, this will be 2. 4 minus 2 over 1 squared, or just 1. The answer's 2. Oh, yeah. I mean, you could simplify, if you want to distribute these in first, great. But I add this, usually I just like, after you derive, plug in, then clean it up. Moving on. 15. Oh, cool. These aren't all too bad. All kind of basic. Some of these. Deriving this. Okay, so f prime is going to be 3/2 times x to the 1/2 power. That's the same thing as 3/2 or root of x. So you plug in f prime of 4. 3/2 times square root of 4. 3/2 times 2. Cancel, cancel. Yeah, get the 3. Cool. Moving on. And the next one. This means derivative of this thing, so I hate when they can't. This is what it looks like. They can't just make it look like this. At x equals 1, so when x equals -1. All right, so we derive this first. Derivative of 1 over x cubed is going to be -3 over x to the 4th. Derivative of 1 over x, okay, and minus 1 over x now will be plus 1 over x squared, and plus 2x. And you do this, sometimes you see notation like this. Done this like line, at x equals -1. You don't have to do that. So I get -3 over -1 to the 4th, 1 over -1 squared, plus 2 times 1. -1 to the 4th is going to be +1, so I'm left with -3. This will also, -1 squared is also positive, then plus 2. My answer, 0. Right, moving on. Did I do attendance? Oh, I'm missing 2. Oops. Oh well, names are on. I think I got them. Yes, question. This one. Wait. This one? Okay. Solved it. 19. Let's go check this. So the following is an equation of a curve that intersects at right angles. Every curve of the family is an equation of a curve that intersects at right angles. What? Okay. You know, sometimes you're like, can't stump me. Then you get stumped. Equation of a curve. Okay. It intersects at right angles. Every curve of the family. Okay, so what is the family y equals 1 over x plus k? All right, this is going to use some algebra skills. You guys get an answer for this? Go ahead and annotate your answer. What did you get? Did one. Kind of curious what you guys would say. So the 1 over x family looks like this. Inverse functions. And then the plus k will shift this up and down, right? So we're looking for something. It intersects, as an equation of a curve, intersects at right angles, every curve of the family. How would you intersect that at right angles? So to intersect at right angles, you're looking at the opposite, reciprocal, slope. You guys remember this a little bit? So, ever heard of this, or like the normal? I think it's the normal they call it sometimes. Looking at opposite reciprocal. So if the slope was like 3/4, the opposite would be -4/3. Something like that. You've ever heard of any of this? Maybe, I don't know. Maybe you have. Maybe you've heard opposite reciprocal for something. This is being perpendicular. Your opposite should flip the fraction, then flip the sign. Or opposite reciprocals. Like, I've never done this. I don't think you did this last year in BC. This is a weird problem, but I'm going to figure this out right now. Like, oh, we just had a bunch of easy problems, and then we have this? Like, what? Okay, so it intersect at right angles every curve of the family. So how would you prove it intersects at right angles? Okay, what is the derivative here? Okay, so we're looking at... Oh, you can't? Oh, my bad. Okay, now you can. So... I feel like that's a dumb question. Okay, natural log of x. So, okay, I'm going to color code this. This is going to be red. Natural log of x function would look like this, right? And then it intersects somewhere. I don't know, man. This is one thing you should learn how to do equations. I'll do this one in yellow. 1/3 x cubed looks like a cubic, something like this. The 1/3 might make it wider, and I don't know where it actually intersects on these. If you want to be -1/3 x cubed, we just like do opposite. We still crossing here. If you wanted to be -x squared, that's just upside down parabola. And then if you wanted to be the line, I don't want to do it in blue, do it in black. -x is just going to be a straight line. Like this. All right? Huh. Every curve of the family. So it would have to intersect every curve. Okay, so I'm going to do my... It can't be this one. Because this doesn't even intersect this curve. The parent function where k is 0. Okay. It also can't be x squared because, again, it's only going to intersect below the graph. I'm going to use my bad deduction rules. It also can't be this one because this ain't intersecting at all. This one. The purple won't. Even if I drew this better, like for this particular graph, it's not. This one is only in the top left, quadrants 2 and 4. The inverse function you can put in quadrants 1 and 3, like the parent function version of it. So the only options I have are the last two. This one will never be in the left quadrant, so it can't. So the answer is D. That's a stupid question, though. Okay, I know the answer is D by my elimination rules right there, but that's definitely not the intention of that problem. I don't know if you followed it. Maybe you followed that a little bit. But I don't know if everyone knows how to graph those. That's one thing I think a lot of times people in calculus miss out. Like, could you just freehand these graphs, right? Like kind of how I did. You know how the parent functions look like? I don't know. But that's kind of a good skill to be able to like kind of eyeball that stuff. So what is the intention of this? The idea is that I think where these intercept, so 1 over x plus k. The idea is I think these should intercept for some value of k. So if we did like times x on both sides, you'd get 1 plus k equals 1/3 x to the 4th. So k is x to the 4th over minus 1. Are you supposed to say, well, it has to exist for some value k, that an x can't equal 0, right? Can't divide by x. I don't see how that helps me, though. Okay, I'm actually gonna look up the answers, what they're trying for this. I hate doing that, but got to. Do I have the answers? Explain it. You get D? Okay, explain that again. So you take the derivative of the original, and you get this. And then you do... The negative reciprocal of this would be what? Okay, regular x squared. Okay. Okay. Oh. Ooh. And that got that. Okay. Wow, that's weird. But that works too, I guess. Now, okay, so if we understand right angles are opposite reciprocal, then you just took this and you said this is the derivative. Well, what's the opposite reciprocal of this? And then you integrated it. And then is that, and that can't even be the intention of this problem either. Okay. Because that's but that does it. Oh, that was fun. Good job. I'm trying. Okay, I want to see what they say. Hold on, I'm going to pause my recording. I don't want... Okay. Sorry, folks, I never unpaused. I'll go back in time on the other ones. Okay, but I'm still doing 31. We'll go back. Okay. So it should be 0. Usually they would say that for this one, it'd be a relative maximum here at 3, x equals 3. But we haven't done those words yet. So our slope is 0. So y minus 5. I'm just doing all the work. 0 times x minus 3. It should be y equals 5. There you go, folks. All right. If you're watching at home, you can skip unless you showed up late. How far I can go back in time. Okay, I'm going to try to... All right. Here's the work for 29 at home. We just derived it. Plugged in -1. I'm going back in time. If you guys want to dip, you can. Class is over. Or you can watch me again. Test tomorrow. This was 7, slope is 7. We plugged in -1 to find the y1. The equation work over here. Pause the video. Moving on. I got to go on everything. Oh. Oh, this is. Oh, I'm just. 27. This ended up being. It is a limit here. So if you did the limit as x approaches 2 for x squared minus 4 over x minus 2, top factors out to x minus 2 times x plus 2. And the bottom's x minus 2. And you'll realize that these cancel. So it's really the limit x goes to 2 of x plus 2, which would be 4. Oops, I said 3 last time. But it doesn't matter. The limit does exist. It is 4. So boom, check. Yes. Is it continuous? Now, its limit's 4, but at 1, but it equals 1 at x equals 2, so it's not continuous. What it actually looks like is a graph of x. So what we do is we have a point. The x plus 2 graph looks like this. But when x equals 2 up here, cross that 2, you have a hole. And that hole actually goes down to 1. It jumps. So we're not continuous, therefore not differentiable. The answer is A. 25, pretty simple product rule. So it's going to be 2x times e to the x plus x squared times derivative e to the x, e to the x. None of those match up, but if you factor it out, you'd actually get a c because you can factor it out, x e to the x. It'll come out to c. All right. This one. Okay, this one. 23, going back in time again. Okay, so what I had to do is derive this f prime of x. I'm going to use the quotient. So quotient rule, it'll be 1 times x plus 2 minus x times 1 all over x plus 2 squared. Cleaning that up, I get x plus 2 minus x over x plus 2 squared. I can cancel out the x's, so it's just 2 over x squared. So you want to find which of these pairs is a slope of 1/2. We're just going to be plugging in basically to this. We only need to plug in the x value to get 1/2. Let's try 0, 0. If you plug in 0, 0, I get 2 over 0 plus 2 squared, which is 2 over 4, 1/2. Those zeros work. Check, check, check. Now let's try 1/2, 1/5, just because. If you tried that one, you would get 2 over 1/2 plus 2 squared. That's going to be 2 over 2.5 squared, which is like 6.25. No. Let's try -4, 2. So if you try -4, 2, get 2 over -4 plus 2 squared, which is 2 over -2 squared. It's 2 over 4, which is 1/2. So boom, that works out. And 4 won't work, so the answer's C. All right. Moving on. 21. Okay, I think last one. I do have to explain the one above. Okay, so C and D, F is differentiable. That means it's also continuous. So to prove continuous, both handoffs have to be equal to each other. So CX plus D equals x squared minus CX. We're going to plug in when x equals 2 because that's the handoff. So it's going to be 2C plus D equals 4 minus 2C. If I add 2C to both sides, I get 4C plus D equals 4. I'm going to leave it like that for now as the equation. Now I'm going to make my f prime right here. F prime is going to be derivative CX plus D is just C, 0. The bottom derivative will be 2x minus C. So I set those equal to each other. C equals 2x minus C. Plug in a 2, C equals 4 minus C. Add a C to both sides. 2C equals 4. Divide by 2, C equals 2. And I plug in over here. I'm going to get 4 times 2 is 8 plus D. equals 4. So D subtract 8 side, D is negative 4. Asking you to add those together, negative 2. Okay, for the last one, 19, this is what we paused at, because this was tripping us up. Oh, I wish I had all my work. Oh well. I'm going to do it again. I spent a lot of time. So my way of doing this is the weirdest. There's 2 ways to do this. I'm going to show you my way. My way is I'm going to look at the graph of 1 over x plus k. The graph of 1 over x plus k is the inverse graph. It looks like this and this. Now, this is where k is equal to 0. You have asymptotes on the axes. Now, the plus k will do vertical shifts up and down, right? So it's supposed to be equation that intersects at right angles. Well, I'm going to draw the rest of my equations. This is how I did it. So to draw, and I'm going to do these in different colors. To draw negative x equation would be like a straight line down like this, crossing at the origin. To draw the negative x squared is an upside down parabola, sad face. All right, to draw, let's go negative 3x cubed. Cubic going down is going to be like this. All right, now 1/3 x cubed is like flip it, the opposite. Going to do this. Crossing at 0, I did a bad job of that. And then the last one, ln of x, is going to do this. Right? That's what natural logs do. Now, if it has to intersect at right angles, every curve of the family, what's going to do this? Now, my answer is, okay, so here's my logic. This doesn't even intersect at all, the line. So no, not that. Negative x squared is not going to intersect every case because it doesn't intersect this top half. I guess it's not really the case. Same thing with negative 1/3 x cubed. I thought that wouldn't be the case. And ln doesn't intersect on the left side. So then I said, oh, it has to be D. That logic, now I think about that, might be a little bit faulty. But here's another explanation we got in class. So to intersect at right angles, we need to do the opposite reciprocal. And if you don't know what opposite reciprocal means with fraction, if I had the fraction 4/3, the opposite, it'd be negative 3/4. You do opposite means flip the sign and then flip the fraction. So opposite sign and then reciprocal of the fraction, rational, no word, you flip it. These are like the slope of, those are the slope of perpendicular lines or opposite reciprocals. And right angles would be perpendicular intersections, or normals, I think called that too. So basically, take this equation, y equals 1 over x plus k, where k is a constant. The slope of that y prime is going to be negative 1 over x squared. What's the opposite of reciprocal of this slope? The opposite reciprocal of that would be positive x squared over 1. So just x squared. Now, which of these would have a slope of x squared? Derivative of this one is x squared. Therefore, it's D. That is the weirdest problem in the world. But there you go. Thank you, everyone. I will stop the video.